Welcome guys, my name is Dr. AVITECH, and in this video we're going to be talking about the Vertex form and how we find maxima and minima. Now, as we already know, the first function where we see maxima and minima is the quadratics. So we're only going to be treating quadratics for now, and this will not be involving any calculus, just how to use the Vertex form to know what maximum and minimum values would be. Now, why is this important? You could tell that in most establishments, some companies, they could actually use an equation to determine the cost of producing, let me say, a number of items in that very company. Now, from that equation, we could tell if there's going to be a maximum supply or a minimum, and what this maximum and minimum would be, and even at what point this would even occur. So it's very, very important. It's very, very important. Now let's take a look at how we want to express the Vertex form and how this can be done. To start with, there's something called perfect squares, or the expressions called perfect squares. Let me give an example. So if we have x plus 3 all to the power of 2, how do we expand this? This would actually become x plus 3 going into x plus 3. Now, if you expand this carefully, this will be x squared plus 3x and then plus 9. Now, this is x squared plus 6x and then plus 9. So that's how the expansion is. Now, what do you notice? I noticed some things. Now, what I noticed was this 3x kind of repeated itself, so it became double to become 6x. So double of 3x will give me 6x. Then the 3 was being squared. This expression is, the result we have here is actually a perfect square. So we could write this in terms of the square of one item. That's x plus 3 squared. Let us also take note of this. Let us imagine we have x plus 5 all squared. Now, same thing. I'm going to say this is x plus 5 into x plus 5. So this is s squared plus 5x. Plus 5x and then plus 25. If you expand, so this is s squared plus 10x and then plus 25. Again, if you notice, the 3x became 6x here, meaning they doubled 3x. So we have double of 5x here, which became 10x. Now, as you can see, I just expanded perfect squares here. It's very important you kind of understand how this is happening. So I expanded the perfect square to give me this expression, also this expression. Now, what do you notice? If this is 10, listen up please, this is 10. If you divide 10 by 2, you get 5, right? And 5 squared is 25. That was how we got s plus 5 squared. It's very, you're going to see how all of this adds up very soon. So every single thing here, these are both squares. But the thing is, when you're given a quadratic, it is not all the time, it is not often that you see perfect squares. It's not often that you see the perfect square. It's not. So the Vertex form utilizes how perfect squares operate. Now, how do they operate? The third guy here, the constant is always the square of half the 6. If you notice, 9 is actually the square of half of 6. So what is the half of 6? Half of 6 is 3. Remember that they doubled it, right? So what is the half of 6? That's 3. Then what is 3 squared? That's 9. This is 10, right? Okay. So what is the half of 10? That's 5. And 5 squared is what? 25. So to complete squares, we must always add the square of half this coefficient of x. That is where you get that for people who have done completing the square method of solving quadratics. When they've done it, there's a particular step that says add the square of half the coefficient of x to both sides. There's a particular step there. So that is why, because we notice that our constant term, this constant term, is always the square of half of these coefficients. So that is why that procedure stays. That's why that procedure stays. Now, what is the Vertex form? The Vertex form is the form y equal a, let me write my a first, a into x minus h squared plus k. If you can conveniently write your expressions like this. If you can, write your quadratic like that. You'll be able to express in vertex form. Now, why is the vertex form very important? Because when you get your vertex form, you can be able to say our vertex is h, comma k. So our vertex is h, comma k. That's what our vertex is. Then we can also be able to get our axis of symmetry, the point where the graph is equal, where one part where we can split our graph into two equal parts. So you can also get your axis of symmetry from that. The axis of symmetry. Okay. Now, please remember, what is vertex? For a quadratic, take a look at this. Let me draw two graphs. Then let me draw this one too. Okay. Now, for a quadratic, that very point, this very point, where the graph is either minimum or maximum is your vertex. The point where your graph is either minimum, because right here it's minimum, like the lowest point it can be. Then right here, it's maximum, the highest point the parabola got up to. So it should either be a minimum or a maximum. That's why we're having this max and min. So it can either be a max or a minimum. It could be any of them. Now let's proceed. Let me check if I'm even recording, because I kind of feel I'm not recording. Okay. I'm recording. Okay, so this has happened before that I wasn't recording. Now let's see. How do we then proceed with this, and how do we start solving problems on this? Let me kind of take the first one. Let me take the first one. So we see, if I was given an expression like this, how would I be able to express it like this? So let's start with the first one. So like the first one, we want to express y equal s squared plus 6x plus 9 in this very form. Y equal a into x minus h squared plus k. So that's what we want to do first. Now, the first step, or should I, let me put this step here, or procedure. The first step, I always love saying that the coefficient of s squared must be 1. So, coefficient of x squared of s squared must be 1. Now, what does this tell me? This tells me that, oh, if it is not 1, I have to divide everything by that very number to make it 1. So it's very important you do so. So we divide everything by that very number to make it 1. So that's the first thing. The second thing I'll do then, also, if it is negative, I factorize, because I should only have s squared. We're going to see that in future questions. Then next, add and subtract. I would explain why this is this. Add and subtract the square of half the coefficient of x to the expression. Yup. Now when you do this, you're going to notice that, oh, you're having, it's like the same thing, because you're adding something, you're also removing it. I would explain why that is. In step number 2, you are unbalancing the equation. In future examples, you're going to learn why that is. In making your vertex form, when you add up something, you kind of unbalanced it. So let me say, this is me. I am an expression, for example. And because you're trying to complete the square, you're trying to make the expression a perfect square, you're trying to write it in vertex form. While trying to do that, you need to add up something to make it a perfect square. Now, when you're trying to add up that very thing, if you add something to me, you're kind of unbalancing what I actually am. So what you then do is to subtract that same thing to make sure that, oh, it is now balanced. That is why you do so. You're going to still learn more of why or how I do that. Then this is number 2. Then number 3, if you do this very part correctly, because that's one thing, most people fail to do it correctly. If you do step number 2 correctly, step number 3, a portion of your expression becomes a perfect square. Let me add this. If you have x plus k all squared, if you have s plus k all squared, your answer will become, let me just expand s plus k into s plus k. So this will be s squared plus kx plus kx plus k squared. So this will be s squared plus 2kx plus k squared. So here's the thing. To get to step number 3, if you notice that, oh, you've picked your x, listen up, you've picked x, s has a squared. The k, there will be a number here that's going to also have a squared. And you check this center, and the center part is actually double of what k is. Then this whole expression becomes a perfect square. Let me say that again. We're going to see that very soon. The first x here is a square. This one is a must. The last guy here is also a square, which is this guy that you're adding. You're adding the square. So it's going to be a square. You also make sure that this guy in the middle is double of this number. Then you have a perfect square. You could just say this is s plus k all squared. Now remember, if you do step number 2 correctly, step number 3 will be good. So a portion, you can factorize a portion, factorize the perfect square portion. Yeah, I'm just going to leave it at 3. Just going to leave it at 3 procedures. So let's get started. Let's see how this is going to happen. Okay, now the thing is, this one might be very, very simple because we could see that that's actually s plus 3 squared. So let's do this, however. So this is y equal s squared plus, this is 6x. Now, this 6 you see here currently, what is the half of 6? That's 3, right? So we're going to add 3 squared to both sides. But if you notice, I think I should use another color. Okay, in future examples, I'll use another color for this. This is plus 3 squared. But it was by your own self, by your own doing, that you added the 3 squared. So to balance up the equation, you ought to say minus 3 squared again. So that these two guys will cancel out. So these two guys will cancel out, making the equation the same. But we're not going to cancel them out though. But the reason for putting the minus is so that we balance up the equation. And then you put a plus 9 here, because the plus 9 has been there. So these two guys are the only new guys. And these new guys, their purpose, the first 3 squared is here to make this a perfect square. That's the reason this first 3 squared is here, to make it a perfect square. Then this minus 3 squared is here to balance up the whole expression. Because when this cancels this, you're going to have 0. So all you have is your original equation. So I believe I've been able to tell you what the 2 would be functioning as. So this is, that's just y equal s squared plus 6x plus 3 squared. So I'm going to keep this part. Let me kind of keep this part separate so you kind of see it separate. And then minus 3 squared plus 9. So right now, what will happen here? I now know that this is x squared, this is 3 squared. And the 6 right here is double of the 3. 6 is double of this 3. So this is going to become s plus 3 all squared. That's what I mean by factorize the perfect square portion. So this portion is going to be the perfect square portion. And then this is minus. You can then expand this one. 3 squared is 9 plus 9. So this is x plus 3 all squared. Minus 9 plus 9 is 0. So you can see that, oh, you've been able to write in Vertex. So that's x plus 3. Now, you might be wondering, what is our plus k in this case? Our plus k will just be plus 0 because we cannot have no number. So the vertex of this graph, the vertex is going to become, if you look at this carefully, it's always h comma k. And the exact form has minus h. So if you compare this to plus 3, this means that our h is minus 3. Take note. Assuming this is minus, right? Assuming this 3 here had a minus 3, that means h would be equal to 3. But the original expression has a minus, but this has a plus 3. So that means this would become what? Minus 3. Okay, let me do it here again. So we have x plus 3 and we have x minus h. When this 2 goes, this side is gone. So we have minus h equal to 3 or equal to plus 3. We kind of need this minus to be on this other side, so h is minus 3. So that's why h is that. And then comma 0. So that's our vertex. That's our vertex. But don't worry, it's not why we're here. Let us go to future problems. Problems that would appear much more tedious. Number 2. Why do I like writing y squared? So y is equal s squared plus, let's say, 12x minus 9. Okay, let's say 12x minus 9. So that's what we have. Let's say this one. Now, if I want to get started, what would I do? I'll say this is y equal to s squared plus 12x. Then if you should take the half of 12, what would you have? You're going to have 6. So I'm going to say this is plus c squared and then minus c squared. And then you put your plus 9. Go away. Put your minus 9, sorry, not plus 9. Remember to hit the subscribe button, like this video, and share it across to your classmates. That's minus 9. So right now, this will be y equal to, remember, the portion I need to make my perfect square is this portion. This is the portion I need to make my perfect square. So right now, this s has a squared, this 6 has a squared, and I'm noticing that this 12 right here is, if I take the half of 12, I'm going to be having 6. So this will become s plus 6 all squared. S plus is all squared. And then what I have outside is minus 36 and minus 9. Take a look at that properly. I have minus 36 and minus 9. Remember I said something. I said, if you notice that the number here, k, is half of this number here, or you notice that, the number right here, this is 12, right? So if you take the half of 12, that's 6. Or if you double 6, that's 12. Then you know they are correct. So make sure that you get step number 2 correctly. Make sure you get it correctly. So this will be y equal s plus 6 all squared. Then minus 36 minus 9. That should be minus 45. Yeah, if I'm not mistaken. Yeah, minus 45. So that's what we have. This is what we have. Yeah, that's what we have. So let me write out what the vertex would. So our vertex will become, the vertex is always in terms of a minus h. So there's always a minus h. But this was plus 6, right? So since this is plus 6 and that's minus, that means we're going to have minus 6. And then k, in this case, is minus 45. And that's just it. That's just what it's going to be. Now, please take note that this part represents your x, this place represents your y. So this is x and this is y. So that's just basically it, and that's easy. So right now, let us step into some advanced problems. Yeah, let us step into some advanced problems. It's not really advanced, please. Don't mind me. It's not really advanced. But let's see. Okay. Number 3. Now we're asked to find the minimum or maximum of this. Oh, I also forgot. Okay, let me explain. I think I didn't put this. Every equation can either be maximum or minimum. Let me explain. Remember that our vertex form is y equal a into this. So I've showed you where h and k will be used. Then let me show you where a is going to be used since what this has been introduced, maximum or minimum. So the a, look at it this way. I kind of drew a graph before. Let me draw it again here. So you can either have this kind of parabola or this type of parabola, any of them. Now this very one is for a less than 0, but this very one is for a greater than 0. So when a is greater than 0, we're going to have a minima. Then if a is less than 0, we're going to have a maxima. So your graph will have max. Max means highest point. Highest point is going to get to. That's how you get your maxima. Then your minima is for quadratic graphs whose a is less than 0. Remember that y is always equal to as squared plus bx plus c. So a is the equation of s squared. And that is the same a that is here. So if this a, you notice that it is less than 0, then you're going to be having a maximum point. And if the A is greater than 0, we're going to be having what? A minimum. In this case, this would be a minimum. This would be a minimum because when you plot this, what you'll be looking at is this. There's a separate graph, there's a separate video about how to plot graphs, sorry. So all of these are all minimum. These are all minimum because x, coefficient of A here is 1, coefficient here is also 1. Well, let's solve this one. Y is equal to x squared plus 14x plus 15. Okay, remember I said that the first thing you should do is, what's it called? Coefficient of x squared should be 1. So let's divide by 2. Divide every single thing here by 2. So y becomes 2x squared all over 2 plus 14x all over 2 plus 15 all over 2. So what we simply did was to divide every single thing by 2. Okay. Now take note, for some reason, do you really think that this is what we should have? Take a look at this properly. If I divide by 2, remember that the original expression did not have a division by 2. I intentionally, by my own doing, introduced the division by 2. So to balance that up, I need to introduce a multiplication by 2. I need to multiply multiplication by 2. So this will then become y equal to, into when 2 cancels out, so this will be x squared plus 7x and then plus 15 over 2. That's one way to do it. Please take note, this is one way to do it. There's another way out. I think, let me use that other way. Sorry. Let me use that other way. There's another way to go about this. I think that way is even better. Hold on. There's another way to go about this. Let's just do that one. There's another way to go about this. So we have y equal to x squared plus 14x plus 15. Now remember that when we're completing the square, the 15 is really of no use yet. It's really of no use yet. Really of no use just yet. So we're only going to be working on these two guys. We're only going to be working on these two guys. So first thing I want to do is, since a coefficient of x squared must be 1, but this is 2 right here, right? Now, can you factorize these two guys? Yes, you can. So we say this is y equal to, open up a bracket, 2x squared divided by 2 is x squared, plus 14x divided by 2 will give me 7x, and then plus 15. As you can see, I just kept the 15 separate. I'm only dealing with these two. Only dealing with those two. So we're going to see how the things would unfold. Okay, now the next thing I want to do is the step number 2. So what is the coefficient of x? What is the coefficient of x? This is 7. Coefficient of x here is what? 7. Now the thing I should square is going to become what? It's going to become half the coefficient. So I'm going to say this is y equal to into x squared plus 7x. Now, what is the next thing I'm going to add? I'm going to add the square of half the coefficient of x. But first of all, what is that coefficient of x? Coefficient of x here is what? 7. So I'm going to be adding up, where is this red guy? So I'm going to be saying plus 7 over 2 squared minus 7 over 2 squared. Yep, that's what I'm going to be doing. Sorry, let me put curly brackets. Okay, and then I'm going to put my plus 15. Please take note. I know this is looking much more big in the eyes, but actually still easy. Look, this is the 2 here. This is the x squared plus 7. This is the plus 15. I introduced these ones by myself. So the plus 7 over 2 squared is here to make this expression a perfect square. Then this very one here is here to balance up the equation. That's why that one is there. So this is y equal to, and then, take a very good look at this. These two, I need these two to multiply this. Okay, wait, let me do something. Since this is x squared, and this is 7 over 2 all squared, and I know that the half of 7 is the same 7 over 2 here. So I can make this a perfect square. So I'll pick the x and pick this 7 over 2. So this is x plus 7 over 2, everything all squared. So these three parts, these three, they're not a perfect square. So that's what is here, x plus 7 over 2 squared. And then I'm going to write my minus 7 over 2 because I've not yet dealt with that one. So I could even just say, I could expand this one, but let me leave it like that first. 7 over 2 all squared. Okay. And then close that guy up plus 15. So this is y equal to now. I need these two to multiply this. I'm kind of opening bracket here. So 2 will times this. 2 would also times this because they are all inside one bracket. They're all enclosed with the 2 outside. So the 2 will times this one. That's 2 into x plus 7 over 2 squared. Then minus. The 2 would also times this. So that's 2 bracket 7 over 2 all squared. And then plus 15. Beautiful. So this is y equal 2 into x plus 7 over 2 squared minus 2. Now let's open this up. This will be 49 over 4. 7 squared is 49, then 2 squared is 4. And then plus 15. Now this is y equal 2 into x plus 7 over 2 squared. Okay, 2 here is 1. 2 into this very 4 will give me 2. So what's going to be left here will become minus 49 over 2. And then plus 15. All right. Okay. So this is y equal 2 into x plus 7 over 2 squared. Now how would this be? Minus 19 over 2. Now, how did I get minus 19 over 2? Yeah, I think there's some space here. Let me use this space. So this is minus 49 over 2 plus 15. I know that I can put over 1 here and take the LCM. So 2 divided by 2 is 1. 1 times minus 49 is minus 49. Plus 2 divided by 1 is 2. Times 15 is 30. So minus 49 plus 30 is minus 19 all over 2. So that was how I got that. Okay. Now, after every single thing that we have done, our A is 2. A is 2. So this means since A is greater than 0, that's a minima or a minimum point. Then our H is what? Minus 7 over 2. Please take note that the H here has a minus with the formula. So if you have a plus here, that means it's going to become minus 7 over 2. And then K is minus 19 over 2. Minus 19. When you compare them together, you're going to have H as minus 7 over 2. So our vertex is going to become minus 7 over 2, comma, minus 19 over 2. So this point right here is our minimum point. So minimum point is minus 7 over 2 and minus 19 over 2. So that's our minimum point. These things are actually easy. So that's what you're going to get. Let's go on to the next question. Question 4 says, the path of a ball is modeled by the equation y equal minus s squared plus 6x plus 7, where x is the horizontal distance in meters from a fence and y is the height in meters above the ground. What is the maximum height of the ball and at what horizontal distance does it occur? Beautiful question. So we all know that when a ball is being shot up in the air, that is, people who play football, it always follows a parabolic curve. So it's like a parabola. Now, so this is the equation of that very parabola. Now we're asked to find the maximum height. So to start with, we have y equal minus s squared plus 6x plus 7. So let us get started by the first one. It should be 1, right? But this is minus 1. So what I'm going to do is to factorize out this minus first. So this is y equal, let's factorize out the minus. So this is minus bracket. Minus will cancel out minus, you have s squared remaining. This is plus 6x, right? So when you divide by a minus, that's minus 6x. And then plus 7. The constant really has no business in this case. So let it just stay on its own separately. This is what we have. This is what we have. If you notice, when you open up the brackets, Minus times s squared is minus s squared. Minus times minus 6s. This will give plus 6x. So it's still the same. Now, the next thing we want to do is step number 2. So this is y equal minus s squared. I think I should use curly brackets. So minus s squared minus 6x. Now, what am I going to be adding? This is where you have to be very, very careful. I'll be adding, they said, take the coefficients of x first, which is minus 6 in this case. So what is the half of minus 6? Half of minus 6 is minus 3. Then you square that. So you're going to square, this is what you're going to be doing. You're going to be adding the square of minus 3. If you notice, I put in the square. In all previous examples, the half of the coefficient has always been a positive number. But in this case, it's negative, so be very careful. So this is plus minus 3 squared, and then minus 3 squared. So what did I just do? I added the minus 3 squared and also subtracted the minus 3 squared. And then my plus 7 comes later. You see that, right? Very beautiful. Okay, so this is y equal to, we have the next one. Let me see. Okay, so this is minus. Now, there are different ways to do this, but let's kind of proceed. So minus, if you look at this first one right here, we have s squared minus 6x plus minus 3 squared. And we know that the minus 3 right here is the half of this minus 6. So this is a perfect square. So we could pick our x and pick our minus 3 and say all squared. So this is x and minus 3 all squared. You could try this out on your own. Expand s minus 3 squared. This is what you're going to be getting. Yeah, this is what you're going to be getting when you expand. Even though you remember that this is 9, in case you get a 9. This is what you're going to be getting. And then this minus, this one is going to still stay here. So minus 3 all squared. I think I should write that in red. So that one will still be there. Minus 3, oh no, sorry. Minus into minus 3 squared. Yeah, it should still be there. And then my plus 7. Now this is y equal to, now I want to expand. Why do I want to expand? Because this is not a perfect square. So I need the minus guy to come outside. So I need this to come outside. Now for this to come outside, I'm kind of expanding, right? So this minus will multiply this one. The minus will times this. And the minus will stay times this. So this is y equal to, where minus multiplies this, I'm going to have minus, open up a bracket, s squared minus 3 squared. When minus multiplies this, this becomes plus. Then I have minus 3 all squared, and then plus 7. Beautiful. Okay, so this is y equal to minus into s squared minus 3 squared. This part remains the same. And then plus, now this guy here, minus 3 squared is 9. And then plus 7. So this is y equal minus s. Hold on. Why am I putting square here? Sorry, there shouldn't be a square right here. S minus 3 squared, and then plus 16. So this right here is my vertex form. What I've just done is to write this in vertex form. So that's just it. So this is now y equal a into x minus h squared plus k. So what is our a? A is going to become what? Minus 1. Now if a is minus 1 is what? Where is it? Minus 1 is less than 0. So you're going to be having a maximum. That was why they said, what is the maximum height? Because a is minus 1. Though you could actually see that from the equation, that this is minus x squared. Then our h, when you compare this, h will be equal to 3. H is directly equal to 3 because these two expressions both have minuses. So h is equal to what? 3. And then what is k? K is equal to 16. K is 16. So let us answer the equations. Yeah, even if you wish, you can actually write vertex if you want to. So the vertex is the highest point it happened. So the vertex will be 3, 16. The vertex will be 3, 16. Because vertex is always in the form h, k. Always in that form h, k. So right now, let's see what this will be. They said, what is the maximum height? come back to this question. Between x and y, which of them is the height? It is y that is the height. It is y that is what? The height. So our y is the height. Now compare these two. What is our y here? The y is what? 16, because s is what? 3. So you then say that the maximum height is 16 meters, because it's in terms of meters. It's 16 meters. And it occurred at a horizontal distance of 3 meters. That's the value of x. That's how you answer it. You know, this graph is kind of looking like this, something like this. Let me see. I don't want to just plot anything, and I don't want to even sketch any curve at all. I'm not interested in doing that at all. But this shouldn't be hard. Yeah, it shouldn't be hard. But let me say I kind of sketch anyhow thing, whatever. So when I do this, they're saying that the maximum height, so the height it gets to here is 16 meters. And that happened at a horizontal distance. So this is horizontal. So that's the x. So be very careful. So this will be the answer. That will be the answer. Let's proceed to the next one. So here we have question 5. The cost in dollars of operating a machine per day is given by the formula C equal 2t squared plus 80t plus 1045, where t is the time in hours the machine would operate. So the first question is, what is the minimum cost of running the machine? And the next one is, for how many hours must the machine run to reach this minimum cost? Okay, so let's get started with Vertex. So C is equal to 2t squared minus 80t plus 1045. Now remember, there's a calculus part of this. You can use calculus to also solve the same problem, but we're not doing that. So this would be C equal, 2 is common. Yeah, 2 is common. So let us bring out 2. So this is 2, open up a bracket. 2t squared divided by 2, that's t squared, minus 80 divided by 2, that's 40. So this is 40t, and then plus 1045. Now, as you can see, we need to take the half of this and then, kind of square what we're squaring. So this will be C equal to into t squared minus 40t. I kind of like putting curly brackets when I get to this part. So I'm going to say, first of all, what is the half of this minus 40? Half of minus 40 is what? Minus 20. So that's what I'm going to square. So I'm going to say add minus 20 squared and also subtract minus 20 squared. Remember, this is minus 40, so you have to be very careful. You must put in the same sign that follows the coefficient that you're picking. And then plus 1045. Okay, so right now, this is C equal to 2. Now, what would happen here? The t has a squared, the minus 20 have a square. These 3 items here, they form a perfect square. So this will be t minus 20 all squared. And then this one will still remain here. So this is minus 20 squared. And then plus 1045. So this is C equal to 2. Now I want to expand. 2 will times this. So this is 2 into t minus 20 squared. Then 2 would also multiply this. So this is minus 2 into minus 20 squared. Look at it. 2 will times this. Then 2 would also times this. And then plus 1045. So we have 2 into t minus 20 squared. And then minus 2. What is minus 20 squared? Minus 20 squared is 400. And then plus 1045. So this is C equal 2 into t minus 20 squared. When you multiply this, you're going to have minus 800. And then plus 1045. So this is C equal 2 into t minus 20 squared minus 800 plus 1045 will give me 245. Yeah, it should give me 245. Now, I am done with expressing in Vertex. I am done with expressing in Vertex. We are done with doing that. So this will be C. Let me just start. A is equal to what? A is equal to 2. So A is greater than 0. So this has to be a minimum. Then we're going to say H, in this case, is 20. Then K is 245. Remember that our vertex is in the form H, K. So that's 20, 245. Yeah, because when you compare the T minus 20 to X minus the H here is this very 20, since we've done previous examples. So right now, the first question says, at what minimum, what's the minimum cost? What's the minimum cost? You know that this is X and this is Y, right? So since our equation is in terms of C and T, it means this is our T and this is our C. That's the meaning. This is T and this is C. So right now, minimum cost. Okay, I need to put that in a sentence. I need to put that in a sentence. I need to put that in a sentence. So this is X and this is Y. So this is, let me just go straight. This is T and this is C. So the minimum cost, minimum cost. Remember to hit the subscribe button, like this video and share it across to your classmates. So the minimum cost of running the machine is $245. $245. Then, how many hours must the machine run? Okay, the machine must run. Okay, let me put and the machine must run for 20 hours. That is T. For 20 hours to reach the minimum cost. So this is actually how you can use vertex form. Even if you have fractions, I think I did one where I had fraction. So it does not matter. You can actually have a fraction. There are equations like that where you're going to have a fraction. So it doesn't change anything. But let me pick one problem that's going to be having a fraction. So you see that this is still very easy to solve. So let's pick one. So let's do number 6. I just want to add it up so you see that vertex form is actually still easy regardless of the numbers you are presented with. So the first thing I want to do here is to factorize that because I want my s squared coefficient to be 1. So this is y equal, I'm going to bring out 3. So 3s squared divided by 3, that's s squared. Now this is minus 5. I'm going to also divide this by 3, but that has no answer, right? So I'm just going to be writing minus 5 over 3x. And then plus 7. Remember, in earlier problems, when we say this divided by this, there's always an answer. But in this case, since the answer is going to be a repeating decimal, just leave it as 5 over 3. Just leave it like that. So this will be y equal to 3. Then open up squiggly brackets or curly brackets. So this is s squared minus 5 over 3x. Now this is where step number 2 comes in. So what is the half of this? What is the half of 5 over 3? No, there's a minus here. So what is the half of minus 5 over 3? That's going to be minus 5 over 6. Here. Now let me do it here. You have minus 5 over 3. When you take the half of it, it's like multiplying by a half. So that will give us minus 5 over 3 times 2, that's 6. So that's what I'm going to be adding. So I'm going to be saying this is plus, minus 5 over 6 all squared. And then minus 5 over 6 all squared. I don't really know what happened to that. Okay. Then I'm going to close this up. And I'm going to say plus 7. That's what we have. Now the next is, this is y equal 3 into, now this x has a squared, the minus 5 over 6 has a squared, and I made sure that the minus 5 over 6 is half of this. So this is now a perfect square. So this is x minus 5 over 6 all squared. So everything here is equal to these 3 items. It's equal to these 3 items. It's equal to the 3. But this one will be remaining. So I'm going to have minus 5 over 6 all squared. And then plus 7. So this is y equal to 3. Let me open up the bracket. So 3 will times this one. So that's x minus 5 over 6 all squared. Then 3 would also times this. So that's minus. There's a minus here. So that's minus 3 into minus 5 over 6 all squared. And then plus 7. So let's see. This is y equal 3. Now this is x minus 5 over 6. It's going to stay like that. And then this is minus 3. Let's open up this guy. Minus 5 squared is 25. And then 6 squared is 36. And then plus 7. Okay, we still need to simplify this. So this is y equal to 3 into x minus 5 over 6 all squared minus 3 here is 1. 3 into this is 12. So you're going to be having 25 all over 12. And then plus 7. Okay. So this is y equal to 3 into x minus 5 over 6 all squared. Now this guy here, hold on. 59. Yeah, I think it should be minus, let me see, plus 59 over 12. But let's do it here. Minus 25 over 12 plus 7 over 1. So the LCM is 12. 12 divided by 12 is 1. 1 times minus 25 is minus 25. Then 12 divided by 1 is 12. 12 times 7 is 84. So what is minus 25 plus 84? So let me say I've got 84. Let me first of all even say that this is just, let me say this is 24. So minus 24. This just give me 60. Just give me 60. Then do not forget that there was a minus 1. So that's 59 over 12. Or you could just use a calculator. So that's just it. So right now, let's compare this to the vertex representation. Y equal a bracket x minus h squared plus k. So what's our a? Our a is equal to 3. This would be what? A minima. Because a is greater than what? 0. Then h will become 5 over 6. H is 5 over 6. This is minus, so that means h would equal to this. And then k is 59 over 12. So the vertex of this guy will become 5 over 6, 59 over 12. So, I think let me add one more thing, because this is the end of the video. Let me just add one more thing. If you have your graph, and this is how it looks like, and this is your point. Let me say these are points. When you take a ruler to pass, because this is x, equal x over, this is the x-axis, this is the y-axis. So at this x part, which is 5 over 6, when you take a line and you cut this, you're going to have your axis of symmetry. You're going to have your axis of what? Symmetry at this very point. So that's how you're going to just draw broken lines. If you are sketching, you just do that. So with this, I'll call this the end of this video. I'm going to see you in the next one. Remain blessed.